Hey everybody, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we are working in Unit 6, Lessons 4 and 5, Forms of Linear Equations. So again, talking about these linear equations, linear functions, um, and working through how we can use different forms, how we can find different information using them. So let's jump in here. Our first question says that a small plastic part can be manufactured in batches of 5 up to a maximum of 50 parts. The cost of a batch of 5 is $12.30. The cost of the next few sizes is $12.80, $13.30, $13.80. We want to write a linear function for the cost in terms of the number of parts, and we also want to include our domain. All right, so a lot of information here. A few things to point out here. These are made in batches of 5, and the maximum that we can make is 50. So in thinking of our domain, the smallest x value that I can have is going to be 5. The largest is going to be 50. So that's really telling me what that domain is. So we would say that x needs to be greater than or equal to 5. It has to be less than or equal to 50. So that's going to be our domain. And then when we think about creating our equation here, or our linear function, we want to think about what is the rate of change. And so the batches that we're given here, a batch of 5 is $12.30. It says the next few sizes, well, we do 5 at a time. So the next batch would be 10, and it costs $12.80. Our next one would be at 15. It costs $13.30. So these are our x values here. These are our y values. And then the last one they gave us, when we make 20, it costs $13.80. And so what we see here, we can figure out, how is that changing each time? Well, it's going up by 50 cents each time in our table. Over here, it's increasing by 5 the number of parts that are being made. And so it's the change in y over the change in x. So our slope is 50 cents divided by 5, which if we simplify that or take 50 cents and divide it by 5, we see that each part is costing 10 cents to make. So that's our slope, 10 cents for every item. We need to figure out what would the value of y be when x is 0. Well, if I subtracted 5 from here to get my x value of 0, I would need to subtract 50 cents from this one, and I would get that $11.80 is the cost when x is 0. So our y-intercept, or that cost when we have 0 parts created, we're starting with a cost of $11.80. So our equation is going to be the 10-cent slope times x, which is the number of parts, plus that $11.80 that we said is our y-intercept, our cost when x is 0. And again, you could check this if I plug in 10 for x. Well, 10 times 10 cents is $1. $1 plus 11.80 is 12.80. So just understanding kind of how that slope, that rate of change, factors in to the idea of an equation. All right, our next question here says, what is the slope of the line that has an x-intercept at x equals 8 and a y-intercept at y equals -6? All right, so if we think about x-intercept of 8, that means when x is 8, y is 0. A y-intercept of -6, that means that when x is 0, y is negative 6. When we're finding slope, remember we are taking the difference between your y values. So 0 minus negative 6, and we're dividing that by the difference between the x values. So our first x value was 8, our second x value is 0. And now we're going to simplify. So 0 minus negative 6, well, remember subtracting a negative is the same as adding a positive. So 0 minus negative 6 would be the same as 0 plus 6, which is just positive 6. 8 minus 0 is positive 8. We could simplify this fraction 6/8. Those are both divisible by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So our slope here would be 3/4 between those 2 points. All right, our last one here says determine the x-intercept and y-intercept of our function 12x minus 8y equals negative 48. All right, well, to find an x-intercept, you can look back at our last problem. X-intercept always has a y value of 0. And so to find that x-intercept, I'm going to plug in 0 for y and solve this equation. Well, 8 times, or negative 8 times 0 is just 0, so I'm just left with 12x equals negative 48. And then to solve for x, I would divide each side by 12, and so I get that x equals negative 4. So my x-intercept is going to be negative 4, 0. My y-intercept always has an x value of 0, so I'm plugging in 0 for x, and I'm solving this for y. 12 times 0 is 0, so this is just negative 8y equals negative 48, and then I would divide each side by negative 8, and I'm left with y equals negative 48 divided by negative 8 is positive 6. So my y-intercept is going to be at 0, 6. So these would be my x and y-intercepts for that particular equation, that function. All right, and that's all I've got for you here on forms of linear equations. Appreciate you taking the time to watch. As always, if you do have questions, please let us know. Thanks. Have a great day.